Example 3. Okay. Similar thing. We have a line, 3x minus 2y minus 6 equals to 0. And what we're going to do is we're going to create another equation of a line that is perpendicular to this line and has an x-intercept of 9. Okay, so those are the two qualities that our new line will have. It'll be perpendicular to this line, and it'll cross the x-axis at 9. With me? So, they want us to, again, write it in slope-intercept form, and then general form. So, to write something in slope-intercept form, again, what do I need? Slope and y-intercept. To find the slope, what could I do?
No, slope-intercept.
Slope formula, could. I need 2 points for that, though. Don't have that. If it's perpendicular to this line, is there anything that I could use from this line to tell me the slope?
3.
I mean, you can't read the slope right now. It's in general form.
Oh, right. So there is nothing. No?
Could you find the slope of this line?
Yeah.
Yeah. And then could you find a slope perpendicular to that line?
Yeah.
Right? Yeah, the negative reciprocal. So let's find the slope of this line, and then the negative reciprocal of that slope to make it perpendicular. Okay? So let's do that. So 3x minus 2y minus 6, putting into slope-intercept form. Bring everything that is not y over.
Can you just bring y over?
You could. Yeah, you're right. And then divide everything by negative 2.
Why negative 2?
Because I didn't bring y over, I just brought the other stuff over. So if you brought y over, you could just divide everything by 2. So that leaves me y. The negative divided by negative gives me positive 3 over 2. And then 6 over negative 2 is negative 3. Okay? So, can you tell me the slope of our new line based on that? What is it?
3 over 2. Or 3 over 2.
Negative 2 over 3. Right? I want it to be perpendicular to this line.
So you have to.
Right? So I need to flip it, throw a negative in front. Okay, so the slope of my new line would be negative 2 over 3. Everybody with me?
Mm-hmm.
Okay. Now the y-intercept.
Negative 3.
Negative.
That's the y-intercept of the other line, but not the one of the new one I'm creating. How do I find that y-intercept?
Solve for y.
Solve for y? It's already solved for. What did we do last time? We took the point and plopped it into the equation for x and y. Right? Do we have a point that we can do that with? Yeah. What are the coordinates of that point? Pardon me? It is the x-intercept. Good. Looking for the coordinates of the x-intercept. Pardon me? 9 and 0. Thank you.
Where'd you get 10 and
Right? If a graph crosses the x-axis at 9,
then it's not
the y-coordinate is 0 because it's not above or below. So the coordinates of that point are 9, 0. Got that? So that's what we're going to use. So we put in 9 for y, 0 for x. No, sorry, I got that backwards. 9 for x, 0 for y. So 0 equals negative 2 over 3 times 9 plus b. Right? So this would be negative 18 over 3. That would be negative 6. And bring the 6 over.
Hey.
Okay, so there's our y-intercept. So this line is perpendicular to this line and has a y-intercept of 9. Right? Let's check that by graphing it. Okay, so let's check to see that these lines are perpendicular. So the original one was 3 over 2 x minus 3. Again, make sure you put your fractions in brackets. That's important. And then the other one was the one we made, negative 2 over 3 x plus 6. And zoom 6 gives you a nice window setting, but to make it look like it could be perpendicular, zoom 5. That takes away the stretching. So do they look perpendicular? Yeah, it does. Right? Does it look like our line crosses at 9? You guys know how to check that? If you press trace, and make sure the equation up here says the one we made. If you trace 9, and it comes out there, right? Comes out at 9, 0, so it crosses the x-axis there. Good?